Good day and welcome back to the Hopkins Demonstration Forest. This is part 6 of What is a Forest? And today I want to continue on that topic about the living and the non-living functions of our forest. And we're going to focus in on 2 of the non-living, or the abiotic. One of them you can see falling from the sky, and on me today, and right here, a device that takes it from the ground and brings it to the surface for us, is water, a non-living abiotic part of the forest. Another thing we're going to talk about is that median that water travels through, underneath our feet, underneath the plants, and how those plants interact with it, the soil. Now, soil does have a living part to it. It also has a non-living. The majority of the soil below us is made up of minerals, non-living parts of our forest. So let's talk about that water real quick. Obviously, why is water important to a forest? Well, much like an animal's habitat, food, water, shelter, the right space and environment, plants need 4 things too. You can probably guess those. The sunlight, the CO2, the carbon dioxide from the air, nutrients in the soil, and that soil so it can reach its roots out and access the water. So those 4 things are very important. And without enough water, a forest may not exist. So depending on the types of trees and species that grow and the plants, you might have a large number of them or just a few of them, or may not have any at all. So you might actually have a definition where a forest begins and starts based on how much rain or precipitation you get. So let's talk about that water and why it's so important for not only us to have healthy forests, which provide us healthy water, but that water and how it gets down into the ground. So that non-living part, the water, it has to go through a series of steps and stages to get into the ground because as you see behind me, there's some large plants, the trees. So when that water falls from the sky, before it gets into the ground and down to those roots, it has a few barriers or obstacles actually. You want to think of them that way. The first is when those raindrops land, kind of like on my jacket here, it's going to get wet. And when I go inside and warm up, that precipitation is going to evaporate. So that evapotranspiration is a word we often use, but the evaporation is part of it. And then the next part is, once that rain falls down, that intercepted rain that falls on the needles, some of it evaporates. It then goes down to the ground and soaks in, and that's where the roots can access it, kind of in that upper part of the soil profile. A lot of fine, small roots are reaching out. That tree, through that process of photosynthesis, using the sunlight, the CO2, the nutrients from the soil, and that water, pulls that water up, and eventually that water transpires. Transpiration. So we have evaporation, and we have transpiration. So evapotranspiration. Before that water even gets a chance to enter that soil and get down, so maybe we can access it, or it gets into our streams and our ponds, it has to go through a few necessary passages. The one being evaporation, but the needed passage or pathway, I should have said, that water goes into the ground and is pulled up through the roots of those plants. So I'm going to use this hand pump right here and take some water out. There's a pipe that goes into the ground. I think they said this well was about 50 feet when it was drilled in. The water, we do actually test here at Hopkins a couple times a year. Any faucets you come to is safe to drink, but even down here, this well has been tested and it's consistently come out with healthy, clean drinking water. So how does that water get down into that soil? And even in the dry parts of the summer, how does that water keep coming out of this pump magically, even if it hasn't rained for many, many months? So I want to talk about that next median, the soil. Because there's lots of reasons soil is important. Provides the nutrients, the mixing of the organics, getting those compounds that the plants need along with the water. If we think of water like this sponge, maybe you've seen this done before, soil is like a sponge. So it allows that water, that non-living part, not just to run down and rain for a day, but when it gets through the evaporation from the intercepted drops on the needles and the leaves, gets down to the ground. What doesn't get taken up from those roots which during this time of year, the plants are just kind of hanging out. They need a little bit of water, but they really need it when it counts. And that's the summertime, when that sun is really pumping that energy into them. So at that time of year, we may not be getting a lot of water. So we think about this sponge as soil, and I know this isn't the easiest example maybe to understand over video, but it's a great thing. You can try this at home under a faucet. As I start to pour some water on there, I'm spilling a little, but you notice what is that sponge doing? It's sucking up the water. And eventually, after enough water starts to fall from the sky in the form of rain, precipitation, and snow, eventually now what happens is the sponge gets saturated, and eventually the soil can no longer hold any more water. They've got names for that, the holding capacity. And we're not here for doing a soil science lesson. I want to really just talk about that water, but notice how the water, I can't get any more in there. So let's say the rain stops. Gravity's kind of pulling out some of that water as it slowly drips. But after a while, it kind of stops dripping. That sponge is holding on to it. There's a pore pressure inside this sponge that allows that water to stay in there. And those little fine roots can kind of tap into that soil, and they've got a little capillary action feature that taps into that water and can pull it out. So even though it just sits there with gravity, I'll take it straight up. So you can kind of think of those roots as applying a little bit of a pressure on the soil in a way, kind of a slurping, sucking straw type effect. But this sponge has a lot of water in it. It takes some energy to force that water out of the sponge. And that's what those roots get to do. So once those roots have done their job and taken the amount of water they need, they don't go actually down that deep. I mean, some plants have very deep root systems. Most of our plants here in the forest, their root systems are actually pretty shallow. So when we get down and access that water, it's down 50, 75, 100 feet, these wells. That soil is doing something else important for us. And by the time that water flows down this hill, I did a shot earlier in a video down by a creek. That water is flowing underneath our feet. As I hiked down here this morning, I didn't see any water on the surface except for the rain. But there's plenty of water down there. Eventually we get down to our creek, this subsurface, the water underneath my feet where this pump is accessing it. Some of that pops up in our pond, in that wetland I showed you, and then even further down by the creek it pops out. When it does, I wouldn't recommend drinking the water, because once water comes to the surface, there's lots of other things, bad bacteria. There is good bacteria out there. But bacteria, animal waste, decomposition, I mean, there's lots of things that are going on from the plants to the animals that are out here in the forest that you don't necessarily want to drink water on the surface without treating it first. But underneath, when that water is flowing in this soil, that soil is acting like a purification, purification plant. So when it comes out into the creeks, it is often very cool. So this water temperature stays the same in the winter. It's actually pretty warm right now, and in the summer I'd feel that same temperature and be, whoo, that's pretty cold. It comes out of the ground with very little sediments, nice temperatures for aquatic species and their habitat needs, and it also comes out clean. Again, for our consumption, maybe not so much, but for the ecosystems and the animals and those aquatic systems that rely on it, very good quality. So hopefully that gives you just a couple more of those non-living functions. The soil, there's a lot more to soil than I just showed you with a sponge. Soil is a pretty amazing, I mean, a lot of people look at the trees and go, wow, look at the forest, but you know what? There's just as much cool stuff going on underneath my feet and underneath these trunks and shrubs, equally cool, and a very important function of our forest. So look forward to seeing you again out here real soon, and have a great day. Thanks a lot.